In mid-October, deep space readouts begin to look uneven. Psyche's public telemetry page shows geometry and deep space network angles updating normally. Yet, downlink windows feel tighter than expected for a long cruise mission, the kind that should be quietly steady by now. Meanwhile, official Psyche materials remind us the spacecraft carried an experimental optical link meant to run through October 2025. Test window that invites scrutiny when any signal looks even slightly irregular. NASA Jet Propulsion Laboratory. Around the same week, reference notes about communications during solar conjunction circulate again. NASA's own guidance explains that when the sun moves between Earth and a target, radiation and geometry can garble or black out signals. Blackouts are normal, planned, predictable, which makes unplanned gaps feel louder. HiRISE, the sharp-eyed camera circling Mars, is well documented to rely on time delay integration across multiple CCDs to achieve its crisp images. That architecture is superb for detail, yet sensitive to acquisition constraints and timing. A pause or delay is explainable, yet the pattern of delays across instruments is the part that invites questions. Across the radio sky, oddities never sleep. Fast radio bursts are cataloged by name and date, including events like FRB 190611, whose host association sits in a careful literature of uncertainties. The point is not any single burst. It is the way rare signals skirt classification, then vanish into our sorting bins. Finally, news cycles turn eyes toward routine meteor showers and seasonal sky shows. Calendars promote Orionids in October and Taurids and Leonids in November, clutter that is beautiful and also noisy. Perfect cover for anything faint that wants to pass unnoticed. Almanac. Taken together, the dashboard geometry, the conjunction warnings, the imaging cadence notes, the fussy literature on weird radio things, and a sky schedule thick with natural streaks do not prove anything on their own. They do, however, build a mood. Silence can be natural. Silence can also be engineered. Tonight we hold that tension and look for fingerprints. These details strain against easy explanations. Here, we slow the pace and assemble them calmly, piece by piece, to test whether the quiet around 3IATLAS is emptiness or a mask. So before our journey begins, take a moment to like the video and subscribe, but only if you feel a genuine connection to the mysteries we explore here. And please, let us know your location and the time when you are. These small markers on the map make our quiet community feel closer even across oceans and deserts. Now, dim the lights. Let the world outside fade away, and let's drift into the cosmos together. We begin with a timestamp and a question. October 19th. Why would multiple unrelated systems develop the same habit of pausing when a single uninvited traveler moves behind the sun's glare, then toward the line where instruments grow careful and committees grow quiet? Conjunction is a shield. It is also a reason that needs no elaboration. We review what the public can see. Psyche's kinematics flow on a minimalist console. The numbers are ordinary, speed, range, angles. Ordinary can be a kind of disguise, the way a soft rain hides footfalls on stone. We log the cautions that mission teams publish years in advance. During conjunctions, noise rises, packets drop, commands pause. A blackout is not scandal. It is physics with sharp edges, which is why the edges matter. The exact hours, the shape of missing lines, the asymmetry between what is risky to send and what is safe to show. We frame a rule for tonight. Assume competence. Assume teams know their sensors. Assume the gaps exist for reasons that would satisfy a review board. Then look for the residue that explanations forget. A repetition in the pauses. A return of cadence that aligns too neatly with a narrow corridor in heliolongitude, a coincidence that grows teeth only when you overlay 3 benign timelines. On another console, a Mars camera lists its design with the pride of a finished instrument: time delay integration, multi-channel readout, high signal to noise. None of these words imply conspiracy. They imply discipline. They also imply that a queue will build if anything upstream hiccups at the wrong minute. This is the place where silence becomes measurable, not as absence, but as pattern. Midnight settles over the quiet suburb, and the room hums like an instrument waiting to be played. The air carries the faint metallic scent of solder and dust. A man sits alone, eyes fixed on a waterfall display. Rows of color, stair-stepped and slow. The dish outside is small, no larger than the hood of a car, tilted toward the darkness. The equipment hums softly, faithful and imperfect. He isn't searching for proof, only for something that shouldn't repeat but does. Old radio logs flicker across the screen. Static. Solar wind hiss. The sharp ticks of passing aircraft. Layer by layer, he strips them away until the sky sounds hollow. Then, beneath the digital noise, a rhythm begins to surface. So faint, it could be the tremor of imagination. Every 2 minutes and 52 seconds, the faintest pulse of energy appears. It rises, flattens, fades, then returns. A heartbeat that doesn't belong to any known beacon. The machine learning filters he'd once trusted would have erased it. Too slow, too irregular, too small to classify. But his analog code catches it, a relic from another era, the kind that listens rather than predicts. He leans closer. The signal is consistent but fragile. It drifts slightly with each night, as though dragged by the slow current of the sun's gravity. When he corrects for Earth's rotation, the rhythm sharpens. When he filters out known satellites, it remains, a small defiance of coincidence. He prints the plots, marks them with pencil, the old-fashioned way. Then he sets a kitchen timer, 172 seconds, and waits. As the clock ticks, the screen blooms again. A thread of silver across black, too deliberate to dismiss, too weak to prove. He adjusts the gain. It breathes in and out like a living thing. Radio astronomers know that most signals die in the margins between our sampling intervals. Our instruments listen in chunks, 10 seconds, 20, a minute, and stack those slices into comfortingly averaged spectra. But a whisper that lives between the slices is easily lost, dissolved by our own habits. It's not the universe that hides from us. It's our algorithms that forget how to dream. He calls a friend in another time zone, someone with different hardware and no shared code. On the second night, at a matching hour, the friend hears something faintly similar. The pulse doesn't line up perfectly, but it rhymes. That's enough to make them both uneasy. Perhaps it's nothing more than geometry. The sun, the earth, and a drifting interstellar fragment forming a temporary mirror. Plasma flicker, Doppler shimmer, chance alignment. But the rhythm survives even when the sun dips below the necessary angle. It persists when no solar interference should exist. The pattern's timing, its indifference to noise, begins to suggest an origin that does not care about us at all. He builds a simple filter, a waveform with a slow rise and soft decay, and slides it across a month of data. False positives fill the screen, then slowly converge around the same hours, those when 3IATLAS should have been closest to conjunction. The correlation is imperfect, but it's persuasive in the quiet way that science sometimes whispers before it shouts. In his notebook, the numbers look unremarkable. Receiver temperature steady at 200 Kelvin equivalent, gain drift within 1%, sample rate adjusted to a neat multiple of 10,000. a controlled, almost comforting list. Nothing about it should inspire awe. Yet somewhere between those figures lives a pattern that refuses to die. He turns the antennas slightly off axis. The pulse weakens but doesn't vanish. Side lobe pickup, maybe. Or maybe something broader, diffuse. Not aimed, but ambient. He doesn't dare call it a signal. Not yet. Not with that word's gravity. For a moment he smiles. Dry. Almost embarrassed. A garage scientist tracing ghosts in the noise. The story sounds ridiculous even to him. But still, he listens. And the whisper keeps its pace. When dawn begins to gray the blinds, he switches to headphones. The demodulated feed is a soft tapping under static, like a coin striking metal somewhere far away, repeating itself with patient indifference. It doesn't sound like intention. It sounds like a test. He writes one line before shutting the lights. If silence is never truly silent, what are we hearing when we think we hear nothing at all? The receiver cools, and the room goes still again. The night gives back its quiet, but something faint continues ticking, far beyond the walls. Lights breathe softly in the lab. The monitors glow in pale rectangles, and the scroll of numbers looks calm enough to be trusted until you look closer. He starts with process, not romance. Pull raw records, note timestamps, rebuild the pipeline exactly as it was before the whisper appeared. Each step wears a good reason. Baseline subtraction to level the floor. Radio frequency interference masks to cut city carriers. Median filters to tame spikes. Time averaging to thicken the signal to noise. Windowing to keep edges clean for the Fourier lens. Every fix helps most days. Tonight they conspire. The first test is simple. He feeds a known synthetic beacon into the chain at a level just above the noise. The pipeline reports it neatly. Frequency and cadence both intact. Confidence warms the room. Then he lowers the beacon to a level that barely rises above the floor and shifts its period to 3 minutes. The output looks tidy again, but the cadence blurs. Averaging has protected the metric while sanding off the rhythm. A real thing has been measured and misheard. A second test replaces the beacon with a tone that drifts slowly. The drift is tiny, the way Earth's spin or a changing temperature in a cable can tug a signal by a few hertz at a time. The pipeline, proud of its stability, treats the drift as something to smooth. It succeeds. The smooth trace looks professional. It is also untrue. Precision has erased the breathing that mattered. He opens the RFI masks and reads the rules as if they were poetry with strict meter. Discard narrowband tones that persist without Doppler character. Discard bursts too slow to match fast transients and too fast to match weather. Discard patterns that activate only near known satellite passes. Each clause is sane. Together they build a narrow gate that favors the familiar over the faint. Filters are not villains. They are the codified memory of a field. But memory can grow impatient with surprise. The plotter draws 3 panels: raw, cleaned, averaged. In the raw, the whisper is a thread that appears and goes dim in a rhythm close to 172 seconds. In the cleaned, the thread still appears but weakens as if embarrassed. In the averaged, the floor looks beautiful. The thread is gone. He did not lose the signal. He chose a definition of quality that rejected it. This is where his voice becomes procedural again. Write down the assumptions. The instrument's response is stable over tens of minutes. The sky background is stationary over similar spans. Interference is better handled by excision than by modeling. Non-stationary features that do not map cleanly to known classes are more often spurious than valuable. None of this is wrong. It is just a worldview that confuses silence with comfort. The next hour is a small anatomy of how signal dies. Time bending hides cadences that land between our favorite intervals and paints them as noise. Frequency averaging compresses lines that wobble exactly where the physics of geometry asks them to wobble. Automatic gain control rescues the listener at the cost of flattening weak breathing that lives at the edge of perception. Spectral kurtosis flags that were built to catch man-made chatter do their job so well that a natural, disciplined repetition begins to look illegal. He removes one aid at a time until the thread returns. Across the bench sits a graph of false positives and false negatives. The old trade everyone swears they understand. In practice, the balance is never neutral. When a field joins a long hunt for brief, bright things, it grows a reflex that favors cleaning aggressively. That reflex is correct for meteors that flare in milliseconds and for bursts that live in the snap of a finger. It is clumsy when a whisper cycles in long breaths, while the world spins slowly under it. The analyst does not blame colleagues he admires. He blames the habit of winning prizes for what is easy to verify. He open codes a bare-bones detector that cares only about temporal longevity. No learning, no classes, just patience. It looks for a shape that rises and rests and falls on the same human-scale cadence, repeated over nights. The detector finds the thread more often than chance, but not always on schedule. When it misses, he checks the geometry and finds that a shoulder of the sun sits near the line that hour. When it hits, the shoulder has moved. It is not proof. It is a hint with teeth. There is a scene worth keeping. The room is quiet enough to hear the fan bearings. On the screen, water runs down the waterfall display in steps the color of dull jade. At the lower right, a line thickens, then thins, then thickens again. In the reflection on the glass, the analyst looks tired and stubborn. That image is not the result. It is a mercy. It reminds him why skepticism needs patience more than it needs volume. 2 firm points help him breathe. Most observatories digest their data in rounded chunks because teams must share pipelines, compare seasons, and publish without drowning readers. The choice keeps projects sane. It can also smear any periodicity that refuses to land on those rounded edges, not by a defect in the sky, but by a convenience in our software. Conjunction does raise noise and scatter. It also creates regular windows in geometry that will modulate what we can hear even if the source never changes. A whisper can look like it blinks when the lobe turns through it. If the modulation matches a clock we did not design, the temptation is to call it artifact. Sometimes it is. Sometimes the artifact is in us. The analyst tests one grounded idea gently. Perhaps the cadence is not a broadcast at all. Perhaps it is the readout tempo of a device that samples plasma density or magnetic orientation on a schedule and vents a trace of energy as a side effect. If the sun's foreground and the object's motion align just so, the side effect could smear into a pattern only when it brushes our beam. The pattern would not care about us. It would care about the sun. We are only a place that rotates under it. He copies the pipeline into 2 folders. One stays clean and elegant. The other grows untidy with toggles. Time bins lengthen and shorten. Averages switch off for an hour, then on. RFI masks loosen. AGC shields come down and go back up. The whisper comes and goes. When it appears, a clock somewhere else in the model seems to keep time. When it vanishes, the loss is often traceable to a decision he made to make the plot look professional. He writes 3 sentences on tape and sticks it to the top of the monitor. Do not sand away the breath you hope to measure. Scrutinize the filters you built when the hunt was different. If it looks like absence, prove it is not a rhythm you failed to hear. With the pipeline exposed and his pride injured in a healthy way, he runs the month again. The pattern survives more than half the nights where geometry would favor it. That is not a victory lap. It is a point on a curve. The other half holds the usual culprits: bad weather, local interference that refuse to be documented, a station reboot at the worst hour, and sometimes clean nothing. Nothing is allowed. Nothing protects a story from becoming a script. He adds one more test that feels like superstition and turns out to be useful. He inverts the detector's prejudice and trains it to find anti-cadence, stretches of time where the whisper should appear by geometry, but does not. These holes reveal the instrument's moods: temperature creep in the rack, a preamp that warms just enough to swell the floor, a lazy cable strain relief. The pipeline has been telling the truth as it understood it. He needed to learn its accent. He steps back from the bench and imagines the thing they are chasing. Not a beacon singing to us, but a device with an inner schedule, untuned to our attention span. If that is true, then the sun is the middleman. Flares and wind density spikes are not random fireworks. They are the way the middleman's face changes as the conversation passes through. The observation does not prove the conversation. It only suggests that the flicker we call noise might be a kind of translation we never considered. What would a translator look like at a stellar scale? Not a codebook in the human sense. A set of conditions that alter how charged particles stream and how magnetic lines bend. A thing that treats the star as the medium and the heliosphere as the page. That thought, while dramatic, still obeys physics. Stars already shape space with winds and fields. A device that rides those shapes would need only to time its touches. We might confuse time touches with coincidence for a long time before we notice. He closes the logs for the night. The quiet returns like surf heard through a wall. He refuses the urge to name the whisper and instead names the error he almost made. He almost equated a well-behaved spectrum with truth. Truth is rarely that polite. A soft, trailing question is enough to carry us forward. If our best filters have been editing the sky to match our expectations, what else have we trained ourselves not to hear? Especially when the sun might be speaking for someone else. Night rolls into a lean, metallic dawn. We return to the sun with a cooler gaze, asking whether its small stutters are weather or choreography, whether a star can translate intentions it does not own. Section openings deserve clarity, so we name the pieces on the table: a moving interstellar body, a corridor of planetary geometry that tightens near conjunction, a sequence of minor solar brightenings that arrive with an impatience that looks like rhythm when plotted against the traveler's path. None of these are proof. Together, they suggest a protocol written in light. We begin with calendars, not theories. The analyst marks 10 days centered on the date when the object skirts closest to the sun's apparent edge from our line of sight. He overlays hourly indices from space weather logs that any student can read without a high-performance cluster. Peaks collect like beads. Some are insignificant brightenings, the sort that barely earn an annotation. Some are modest, a nudge above quiet. When these peaks are set against the traveler's projected heliolongitude, a curve emerges that does not care about our preference for tidy explanations. He builds the simplest posture a scientist can take. Assume the sun is indifferent. Assume the peaks are random within known cycles. Assume the object is exactly what its inertia says it is, nothing more. Then ask how often a blind, indifferent sun will place bursts inside the narrow watching windows made by our moving geometry. If the answer is often, the story sleeps. If the answer is rare, we stay awake and count again. Counting is not glamorous, so we keep it clustered. Time bins of 5 minutes. Brightening thresholds set to round values so small changes in calibration do not swing the result. Known flare classes group simply into quiet, minor, and modest. Background proton density recorded hourly. Alphen speeds estimated in round thousands of kilometers per second. A single line of geometry for the traveler's sky position updated on the half hour. This is housekeeping. It is also the way a pattern proves it is not a trick of our plotting hand. On the third pass, the alignment sharpens. Peaks avoid the hours where the line to the traveler slips deepest behind the sun, and then bloom again when the geometry relaxes. The bloom is not loud. It is persistent. When he spreads the window to include earlier weeks, the persistence weakens but does not vanish. When he tightens around the 10 days, the persistence brightens, like chalk discoveries that show only when the board is cleaned just right. The image to hold is simple. A tremor moves through the star at a human pace, as if a long wave is being tugged and released. Every 2 to 3 minutes, a ripple rises, holds, and falls in the data from a small patch on the sun's skin. This is not new to solar physics. Flares often carry quasi-periodic pulsations that live at scales from tens of seconds to a few minutes. Magnetic loops resonate. Waves reflect. Reconnection can stitch and unstitch on a heartbeat that is not quite regular. But the precise hours chosen by these pulses, the way they collect in the corridor where the traveler stands in our line of sight, raises a practical question. Are we seeing a star's private resonance? Or are we watching a sympathetic vibration tuned by something moving through the wind that feeds the star's near space? It is tempting to leap. Instead, we step. He models a toy universe in which a small charged structure rides the heliospheric flow and alters local density and field orientation on a schedule of its own. Most of the time, that structure is meaningless to us. Now and then, the altered flow lines bend through a region where the sun is primed to flare even on a minor scale. The structure does not cause the flare in the cinematic sense. It nudges conditions, sets timing, and lets the star spend its own energy in the way a reed encourages a note from air that would have moved anyway. If this is true, then we expect a few practical traces. The brightenings that correlate with the traveler's corridor should be modest and frequent rather than heroic. Their energy should sit at the lower end of familiar classes, because we are catching timing, not violence. The pulsations should land in rounded periods that match the easy resonances of coronal loops. Their spatial footprints should track active regions that were already alive, not dead skin suddenly shocked awake. The data behaves with that modesty more often than chance should allow. He tries to break the idea by consulting the natural culprits. There are well-known cycles that throw off bursts like a heartbeat, regardless of visitors. A large coronal hole can breathe at a steady pace. Active regions walk across the disk in a regular procession. When he subtracts those expected parades, the residual still leans toward the corridor hours. Not dramatically, just enough to keep your pulse slower than your curiosity. He resists drawing lines to anything more exotic. It is enough, for now, to imagine a simple tuning fork that passes near the sun and lets the star sing on its own. If the fork's timing is set elsewhere, perhaps very far away, then our local observation is only the echo of a choice we cannot see. That thought sounds grand until you remember that resonance is the quietest of conspirators. Bridges sway when small feet walk in step. Gas pipes hum when a distant pump cycles on the even minute. The universe does not need to shout when rhythm can carry a message across a crowded room. A practical question matters more than poetry. How would a receiver ride a star? Our options are not endless. One can imagine a conductive body with a sheath that charges and discharges as it moves through varying wind conditions, a surface that reshapes the path of particles in a tight neighborhood. One can imagine a small magnetic architecture, nothing like a planet's field, just enough to tilt local lines and make reconnection slightly easier on a schedule. One can imagine a device that carries no field of its own, but samples the environment and vents a trickle of material and pulses that are slow by radio standards and fast by human patience. None of these ideas offend physics. Each returns us to the same restraint. The star does the loud work. The traveler keeps time. We bring the tuned eye back to the counts. Over 10 days, the modest brightenings cluster inside observation windows more often than a fair die would permit, if thrown for the same number of trials. The exact odds are less important than the discipline to compute them with humility. 1,000 ways exist to cook significance when you stare at a wall of numbers long enough. So he gives himself unromantic guardrails. Fix the window before you look. Fix the thresholds before you count. Refuse to throw out ugly nights unless weather or hardware truly destroyed the log. With those guardrails, the pattern bends but does not break. From a distance, this all feels suspiciously tidy. The closer view is messier. Some hours refuse to cooperate. Some pulses arrive early, then go flat and never repeat. Some nights pretend indifference. The map is not a codebook. It is a page with coffee stains where the sentence still reads, if you are patient. He suspects that is what physics feels like, when you chase the edge of a system that does not care if you read it. There is a small grace in admitting limits. Solar pulsations at 2 or 3 minutes will never sound like a clear voice line. They are umbrellas in rain. They are dance cues buried inside a song you only half remember. We can leverage them without pretending they carry words. If a cadence turns the sun into a translator, then the translator speaks with a heavy accent and a fondness for repetition that lulls the untrained ear. That is fine. This is, after all, a documentary for sleep. We are allowed to be patient with the star. The analyst pins a simple plot to the wall. 10 vertical strips for 10 days. Each strip shows hours on one side and geometry on the other. Brightenings appear as small dots the size of a pencil's blunt point. A faint diagonal line drifts through the strips where the traveler's corridor crosses our view. The dots thicken along the diagonal. It is not a mural. It is a suggestion strong enough to invite the next question. If the sun is singing on borrowed timing, how do we prove the borrower exists without asking the star to stop? We cannot command a pause. We can only change how we listen, from brief, bright expectations to the longer breath that a translator prefers. We end this segment with a pocket thought to carry. The star may not be speaking to us, yet its voice can still carry meaning here. That is enough for tonight. A thin breath of morning air slides under the lab door. Coffee cools. The graphs from last night wait like maps left open on a quiet table. We turn the page from timing to texture, from the cadence of brightenings to the fingerprints they might leave in a field we cannot see, only infer. 30 words to set the stake. If a traveler can nudge solar timing, it must touch the medium that carries timing best. That medium is plasma shaped by magnetic lines. Imagine the heliosphere as an orchestra of invisible strings, each line a path that charged particles prefer. The strings are not still. They vibrate slowly, carrying waves that rise and fall like tides. A traveler sliding through such a room will feel drag that is not friction in the ordinary sense. It is a coupling between motion, charge, and the elastic memory of the field. We keep the numbers together so they do not drown the story. Near Earth, the solar wind density sits near 5 particles per cubic centimeter on a quiet day, with speeds around 400 kilometers per second. The Alfvén speed in that neighborhood often lands in the 100 kilometers per second range. Gyro-radii for protons at those speeds live around thousands of meters. At smaller scales, a Debye length of a few meters sets how thin an electrical sheath can be. Magnetic Reynolds numbers are huge across heliospheric distances, so field lines are mostly frozen into the flow. These are round figures, faithful enough for a journey and polite enough for sleep. From those figures, the first picture forms. An object with even a weak magnetic skin passing through such wind will pick up a sheath of charge. The sheath breathes as the wind changes. If the object rotates, the sheath rotates with it, and the motion modulates how local field lines bend around the body. None of this is literary invention. It is the same set of rules that shapes a faint comet's plasma tail, or the way a small moon's atmosphere carves a footprint in a giant planet's magnetosphere. A second picture forms when composition enters the room. If the traveler carries nickel and iron in a lopsided core, it can hold a modest remnant magnetization once it is soaked long enough in a prevailing field. The magnetization does not need to be heroic. A whisper of moment, aligned and then tilted by rotation, can change how reconnection chooses a place and a time inside a restless coronal loop. The sun keeps the energy. The traveler keeps time. We test these ideas with the simplest tools at hand. The analyst writes a toy model in which a conductive rod, elongated and rough, flies through a wind that holds a uniform field. The rod rotates slowly, producing a small, repeating tilt between its long axis and the field lines. A sheath forms and sheds, never perfectly symmetric. In the wake behind the rod, the model shows a slight enhancement of current that arrives in pulses. When the wake brushes a pre-existing magnetic loop near the star, the loop relaxes in short, uneven bursts. The periods match the rotation within a few percent when geometry privileges the view. When geometry spoils it, the bursts smudge into what most pipelines call noise. The beauty of small effects is that they leave modest traces. Two of those traces are within reach of ground-based listeners. First, Faraday rotation changes gently when a polarized radio source shines through plasma whose density and field orientation are being nudged. The rotation angle drifts in step with the nudge. Second, depolarization increases when waves pass through a region whose magnetic texture becomes patchy on scales comparable to the wavelength. These are not smoking guns. They are precise ways to ask whether the sky is slightly rougher than it used to be. So we look for roughness in old logs. There is a habit in radio astronomy to average rotation measures over hours for stability. The habit is good. It protects analysis from atmospheric drama. It also hides the kind of slow pulse that a rotating sheath might write. The analyst returns to archives that keep raw polarization every minute. The nights near the corridor look a little messier than neighbors. Not always. Enough to be interesting. Enough to make one wonder how much of our calm is bookkeeping. The lab itself becomes a rehearsal space for the field. A coil sits on the bench, a small field inside it controlled by a power supply that can be taught to stutter gently. A graphite rod with a metal cap is placed inside. In a saltwater bath, the rod's sheath forms and reforms as the coil ticks a pattern. A laser pointer and a polarizer look through the bath and see the pointer's plane of light rotate by a whisper of angle at each tick. It is not a star. It is not the sun. But it reminds us that small fields can alter paths when the medium cooperates. Skepticism remains the safest posture in the room. A repeating roughness and polarization could come from many sources that do not care about the traveler. Ionospheric moods, instruments desperate to drift by a fixed fraction of a degree, and doing so with loyalty to a temperature log. Satellite constellations playing roulette with line of sight. Each culprit earns a seat and a chance to confess. None confess completely. The case does not close. The case does not collapse either. There's another path to fingerprints. One step upstream of the eye, we turn to the sun. If small magnetic structures move with the traveler, the solar wind should feel them as perturbations long before light tells any story. Spacecraft scattered through the inner system listen to the wind's dynamic pressure and magnetic field vectors as a matter of routine. On quiet days, the plots look like lazily waving grass. On certain hours, they show comb teeth that return at human-friendly intervals. Catalogs call them quasi-periodic structures. The label does not name the cause. It names the rhythm. In our 10-day window, the comb teeth appear more often than they should if chance were in charge. The amplitudes are small, at the edge of normal, the way an almost silent metronome still shapes how a musician breathes. When those teeth overlap with geometry that places the traveler's corridor near our line, the teeth feel less random. We do not carve a message in them. We admit a pattern and ask how many ordinary things can still explain it. There's also the question of shape. If 3IATLAS is long, with ends that taper, its interaction with the wind will change as it rotates. An elongated conductor moving through a field prefers orientations. It might accumulate charge at its tips, venting in a way that repeats only when those tips face the flow at certain angles. The repetition looks like someone tapping a rail far away. No words, just timing. 2 hard anchors keep our feet on the ground. Magnetic reconnection on the sun is already known to produce pulses that land in the minutes. No traveler required. And comets regularly write magnetic signatures into the wind at scales that instruments can read. The novelty here would not be the existence of pulses or signatures. It would be the alignment of their choice of hours with a moving corridor traced by a single body. The most tempting narrative leap is to call such alignment intention. The safer step is to call it a tuning opportunity. In this step, the traveler does not need intelligence to choreograph. It needs a schedule. The schedule could be written by rotation, by an internal relaxation time, or by a very simple controller that samples and vents at steady intervals. Intelligence is not forbidden. It is not required to reach the observation we have. What would make the observation braver is a prediction that risks embarrassment. Here is one. If the traveler's sheath and shape are doing work, then the polarization angle of background sources that graze the same corridor should drift with a small bias toward one sign during the hours when brightenings prefer to appear. The bias should reverse as the rotation carries the opposite face into the flow. The swing should be small, a few degrees at most when averaged over minutes. The swing should widen slightly on nights when the wind is fast and the alpha speed is low. That is testable. That is enough. A small picture to hold while we close the notebook for this session. A lighthouse turns behind fog. We do not hear a horn. We do see the fog thicken and thin on a rhythm that is steady enough to lend courage to patience. We treat the thickening as a magnetic signature written in a medium that loves rhythm more than it loves punctuation. One gentle question is worth keeping in a back pocket as we walk away. If a traveler can write timing into a star by leaning on fields and flow, how many other quiet travelers would pass unnoticed because we sanded their softest strokes away? We clean the bench, we pin the prediction above the desk, we let the coffee go cold and decide that cold coffee is good enough for a morning built from small fields and smaller certainties. We leave a single line as the corridor of hours returns. The sun might be playing its own song. We are learning to hear a second instrument that keeps time just under the melody. Dawn climbs the blinds in pale bars. The room looks smaller in the soft light, as if the machines have pulled their shoulders in to think. We have counted pulses and looked for fingerprints. The next step is uncomfortable because it asks us to change the furniture in our minds. We stop treating the sun as a background lamp. We ask whether it can serve as a translator that never signed up for the job. Picture a quiet harbor at low tide. Mooring ropes stretch from boat to dock, slack in places, taut in others. A small tug glides through, barely stirring the surface, and yet its wake tugs each rope a little. First this one, then the next. Nothing dramatic, just an orderly sequence of pulls that would be invisible without the ropes. That is the image that holds as we return to our star. A field of lines stretched through a bright sea, a traveler passing among them like a deliberate tug, and a chain of low-tide tugs that look like timing. If the sun can be a translator, then the language would be rhythm written to a medium that already loves rhythm. Magnetic loops do not need permission to ring. Reconnection does not need a script to choose an opportune moment. All they require is a nudge that arrives within a window of readiness. The traveler brings the nudge. The star supplies the volume. A translation device at stellar scale would, therefore, be underwhelming up close and overrepresented at a distance. It would be boring to a nearby camera and persuasive in a long plot that stacks hours until a pattern appears. Two anchors steady the idea. First, quasi-periodic pulsations in solar and stellar flares are common at scales from tens of seconds to minutes. They do not imply intelligence. They imply structure capable of resonant response. Second, small bodies already modulate plasma and fields in ways we can measure. Comets leave ionic tails that deflect magnetic lines and carve current sheets. Tiny moons write footprints. These are not metaphors. They are laboratory entries that insist the medium keeps score even when the player is small. That gives a shape to the translator, not a broadcaster beaming clean messages, but a metronome that hands the sun small opportunities to place energy in time. The content of the message would not live in a human alphabet. It would live in the schedule of when energy is released and where. If someone chose to use such a schedule, the star would never cease being itself. It would simply breathe on cue. Skepticism is invited to sit in the front row, arms crossed. If rhythm is the content, statistics must be the proof. We have already counted brightenings inside windows and seen a lean toward the corridor hours. Now we ask for a second kind of support, coherence across instruments that do not talk to each other. If the sun is being nudged, then small signs of that timing should echo in independent logs. Wind pressure, magnetic vector wobbles, polarization drift of background sources. The echoes will be small and often out of phase, but they should gather around the same slices of time. Last night's plots offered modest encouragement. Modest is important. Overconfidence would be an injury to the truth we hope for. There's a wider implication that changes how we listen beyond the sun. If a translator exists here, it might exist anywhere that fields and flows are abundant. Stars would be natural hubs. A star could become a relay, a center that turns a private cadence into public weather, ripples in radio noise, faint signatures in particle counts, tiny changes in the efficiency of reconnection. A message network, if it exists, would look nothing like our towers and cables. It would look like a lattice of patient nudges that borrow the lungs of stars. By this logic, the traveler does not need to speak loudly. It needs to keep time and choose positions that make timing matter. It might be a shape conductor with a breathing sheath. It might carry a small internal field that tilts as it rotates. It might carry nothing except a schedule and a habit of venting a whisper of material when the sun is ready to sing. The intelligence required could be thin. The discipline required would be absolute. We test discipline by asking the model to predict something uncomfortable, something that can fail. The prediction is not romantic. If the sun is being timed, then the distribution of minor brightenings over a 10-day window should show an asymmetry when viewed in the traveler's co-rotating frame. In that frame, brightenings should lean toward phases where the object's long axis aligns with certain field orientations. The lean should depend weakly on wind speed and more strongly on the angle between rotation axis and the field. If we cannot find this lean, the idea weakens. If we can, it grows braver. The first pass shows a hint that refuses to go away when we tidy the data, not a confession, a nudge. A quiet consequence appears in the radio sky. In catalogs of transients, there are events that flicker too briefly to live comfortably as stars, and too neatly to live comfortably as noise. They arrive, ring, and disappear into our thicket of labels. If a stellar translator is part of the environment, it would color how we interpret such events. Some fits would improve by allowing a slow external metronome to gate a local instability. Others would stay unchanged. The point is not to colonize the sky with a single explanation. It is to admit that timing might leak across systems more often than we assume. This is where humility is needed most. It is easy to draft the sun into an espionage story and call every coincidence a sign. We do the opposite. We keep the coincidences on a short leash. We accept that our instruments love rounded bins and tidy averages. We accept that our own attention sharpens at midnight. Then, inside those admissions, we find a residue that still prefers the traveler's corridor when it should not prefer anything at all. A small, stubborn reality helps. The sun's surface and low corona are not uniform. They are threaded by regions that lean toward activity on their own schedules. If an external cadence is writing those preferences, then it will never look like a switch turning on and off. It will look like a hand that presses gently when the muscle is already ready to move. Every press will be a little different. The hope is not for perfection. The hope is for a bias that survives cleaning. Another reality. A translator this shy would be terrible at carrying information the way we carry sentences. That might be the point. A relay that lives in physics would rarely be used to convey exact phrases to strangers. It would be used to maintain coordination among things that already share a basis for meaning. Clocks align, windows open, doors close. That is all. Meaning happens elsewhere. The analyst tapes a fresh sheet over yesterday's plot. He sketches the star as a circle, the traveler as a sliver, and draws a slow spiral to represent their changing geometry as seen from Earth. He dots times along the spiral where brightenings were logged. The dots bunch along certain angles. Then he adds arrows to show the field orientation inferred from wind measurements that day. The bunches offset from the arrows by a modest, consistent angle. The offset is within the margin where reconnection would become easier if a foreign, rotating sheath tilted the local lines. It is the kind of mundane alignment that never appears in dramatic posters and often matters most. We acknowledge that none of this is comfortable to publish without caveats that triple the length of any claim. We remember that journals punish romance and reward caution. Good. Caution is what saves new ideas from enthusiastic self-harm. But we are not writing a paper in this room. We are building a listening posture for the 10 days that will decide whether the message we think we see survives or dissolves. So the sun is rewritten, not as a conspirator, but as a willing medium. It is a stage that will host timing if timing shows up. The traveler is rewritten, not as a herald with words, but as a performer who knows the stage's acoustics and places steps where the boards ring. A theater that spans a planetary system is an extravagant image. The physics behind it is plain. Fields, flows, and resonance do not care about our metaphors. They care about timing. We bring one more ordinary fact into the light. when small, persistent clocks interact with large, noisy systems. The large system often looks unchanged to casual measurement and yet grows strangely cooperative in narrow windows. Engineers know this in power grids. Oceanographers know it in tides that amplify in specific bays. Physicists know it in plasmas that break into islands at predictable intervals. The sun is not exempt. Our job is to learn when and where to notice. The room hushes as the hour changes. Somewhere in the data stream, a minor region flirts with a flicker. The display records a slight rise, holds for a breath, and lets go. In the next minute, a background source's polarization drifts by a sliver. The magnetic vector in the wind plot tilts and returns as if someone adjusted a picture frame on a wall. None of it is glorious, all of it is oddly timely. We leave the machines to log without drama and step outside. Morning has taken hold. The sky is a thin blue sheet stretched tight. A raven crosses the street in a straight line as if it had been told to keep time. The world is ordinary, which is the right camouflage for interesting things. It is time to turn the question inward. If the sun can be a translator, what exactly is being translated? Chemistry, perhaps? Timing embedded in the way a body releases or reabsorbs a sheath. Geometry, certainly, in the angle between a long shape and a field that wants to be straight. And maybe something like a dress. Information coded not in syntax, but in ratios that describe where a thing was made. That last possibility needs its own room. We carry one last quiet thought to the door. Sometimes the way to hear a voice is to stand near the wall it bounces from, not the speaker itself. The sun may be our wall. If the echo has rhythm, we can use it. Section 2 closes on a held note. Next, we stop listening for the sun and begin decoding the message layered in chemistry, time, and intention. The address comes first, then the clock, then the act. We proceed with care and with the modest bravery required to test a hope. The night has thinned to a sober blue, and the machines hum with the steady confidence of habit. We have listened to timing through a star. Now we change posture. We look for where the traveler was made, not where it currently wanders. Composition is a memory written in atoms, and memory can be mapped. The first truth is plain. Origins leave ratios. In stellar nurseries, supernovae salt the gas with heavy elements, and the mix drifts along the spiral arms, changing by small, patient amounts. A body that condenses from that gas carries a signature that outlives its path. If we can read even a fragment of that signature, we can sketch an address. We begin with 2 pockets of evidence that survive sunlight and distance. Metals in the grain, volatiles in the frost. Nickel to iron makes a simple handle in the dust. Carbon dioxide to water carries a handle in the ice. We do not need perfect numbers. We need a bias that refuses to vanish when measured in different ways by different hands. The lab table is honest about what can be done. Spectra are blunt instruments compared to touch. Reflected sunlight tells more about surfaces than interiors. Gas seen in a tail tells more about what was freed than what still sleeps. So we keep the technicals in one breath and step back. For metals, we track how the reflected spectrum bends around the red and near infrared, then compare against libraries where nickel and iron proportions were varied in round steps. For volatiles, we monitor the relative strengths of bands that usually indicate water and carbon-bearing molecules when the visitor flares slightly. The band ratios wobble with geometry and heat, but their average sits stubbornly in a band that is not arbitrary. Hold one image to help the mind. A stone with a rough, elongated body, its skin darkened by space weathering, carrying fine grains where nickel is not scarce and not rich, near familiar. while the thin frost in its pores gives up carbon dioxide more readily than water when warmed. The picture is coarse. Coarse is enough. 2 hard anchors steady that picture. In our galaxy, the ratio of nickel to iron in long-lived stars tends to stay close to the solar proportion, wandering by tenths in logarithmic measure as you move several kiloparsecs. Small deviations cluster with birthplaces, and those deviations do not smear to zero even after orbits mix. Meanwhile, in icy bodies, the proportion of carbon dioxide to water ice can vary widely, but populations show tendencies tied to where sunlight and chemistry first struck. In round numbers, many comets hover near a few tens of % for CO2 relative to H2O, with families leaning higher or lower in recognizably different ways. The quiet gamble is to treat these two tendencies as axes on a map. We build an address space with metal ratio along one line and volatile ratio along the other. We overlay the gentle gradients of the Milky Way's disk, metallicity flattening near the inner arm, carbon chemistry shifting outward with the cooler gas. The address space is not a street grid. It is a climate chart, and we are trying to place a traveler by its weathered accent. When we do, a sector emerges. Not a point you could visit, but a wedge where both biases feel at home. Nickel to iron whispers, not too far from solar, perhaps slightly lean, a hint that fits regions a few thousand light years outward from the sun more comfortably than inward. Carbon dioxide to water leans more generous, a tendency that prefers colder, slower kitchens in the outer disk over the warmer inner gas. The overlap is a diagonal band arcing through one quadrant when seen from our position. It is wide enough to be humble and narrow enough to be useful. A gentle speculative step follows, still tied to physics. If a body was forged in a slightly lean metallicity neighborhood farther out, then drifted inward over long ages, it would carry both the metal accent of its birthplace and the volatile habits of a colder nursery. The ratio map would not betray the exact star that fed it. It would point to a district of the galaxy that speaks with the same vowels. We do not pretend that metal ratio alone seals the case. Isotopes keep the door open for more detail. The heavy hydrogen in water, deuterium, varies across the disk and within families of small bodies. Oxygen isotopes arrange in clusters that betray histories of exchange and heating. If the traveler could be persuaded to shed enough vapor for a clean reading, then a secondary compass would swing. But we do not force the story to bear numbers it cannot carry tonight. We pin a note. If DH swings high while oxygen skews modestly, the diagonal band tightens. If both sit near solar, the band shifts closer to us. Either way, the method remains the same. Chemistry to climate, climate to quadrant. A small, vivid scene helps the abstraction. Imagine standing on a dark plain looking at a city far away. You cannot see the street signs, but you can tell the district by the color of the lights and the rhythm of traffic. The traveler's lights are the nickel and iron glowing dull under a thin skin, and the traffic is the way carbon dioxide leaves faster than water in the first breath of warmth. The district is not guessed. It is inferred in patient circles. We place one more practical fence around the map. Galactic gradients are not straight rulers. Spiral arms bend the rules. Star formation waves roll through and leave pockets heavier or lighter than neighbors. A single body might carry fingerprints from more than one neighborhood if its material was mixed before it hardened. To defend against that, we ask the address to make a prediction that can fail gracefully. If the sector is outward and slightly lean, then other elements in the spectrum, chromium, cobalt, should lean in the same direction by smaller amounts. If future observations hint the opposite, we adjust the band without shame. The goal is not to be right quickly, it is to be wrong in ways that teach. There is an older discipline that smiles at this approach: galactic archaeology. Astronomers have long read star chemistry the way historians read dialect, grouping families into moving streams by shared abundances. We borrow that habit and apply it to a fragment that does not shine on its own. It is a quiet theft, dignified by gratitude. The numbers return for short, contained appearance. Metallicity gradients in the thin disk change by a few hundredths of a logarithmic unit per 1,000 light-years. Within that, nickel to iron wanders by similar amounts among populations. Volatile ratios in ices spread broadly, but families cluster. In round words, a shift of a few thousand light-years can tilt the expected mix by fractions that become visible if you can measure cleanly and average long. Those fractions are small enough to respect and large enough to steer us away from fantasy. There is one more hinge to test: how the address plays with the timing we already suspect. If the traveler's schedule is disciplined, and if its chemistry points outward, then its long axis and spin could be relics of a formation environment where collisions were slow and alignment with local fields mattered more than it would in a hotter inner disk. That would leave a geometry that favors the elongated shape we have been picturing and a rotation period that lives comfortably in the minutes when translated by interaction with the sun. The hinge does not lock the door. It keeps it from swinging wild. We do not hide the awkwardness. Composition can be edited by time. Space weathering reddens and flattens reflectance. Heating distills the first, gentlest volatiles and leaves the stubborn behind. Cracks open, frost settles, rims darken, an address can go out of date, but some handwriting survives. Nickel to iron, in deeper grains, laughs at sunburn. The average behavior of carbon-bearing frost over many small warmings still leans the same way, like a dialect that softens in a new country, but never quite disappears. We return to the map on the wall. The diagonal band still arcs across that quadrant, the one we mark with a small note. Outer disk leaning, modestly metal lean, volatile friendly. It is not a star chart with a red X. It is a weather report that says you are smelling sea air, so the ocean is likely that way. A small pragmatic test sits within reach of those with patient telescopes. In the nights ahead, background stars that the traveler passes near, by angle, not by distance, can be sampled for slight color and polarization changes as their light grazes any exhaled dust. The grain size distribution inferred from those changes should favor the smaller particles expected if carbon dioxide is the early driver of activity. If the grains look too large too soon, the address leans inward. If they stay fine before thickening, the address leans outward and colder. This is not glamour. It is a kitchen scale, and kitchen scales win more arguments than speeches. We keep the voice calm because the idea is simple. A star can translate timing. Chemistry can indicate an origin. Place the two together and you begin to see a kind of message that is not a sentence, but a letterhead. Who is this from, approximately? Which neighborhood taught it to speak this way? That is what address means here. Not a set of coordinates, but a return address in tone and paper grain. And a quiet question lingers, patient and kind. If we can place a body by its accent, how many other travelers have crossed quietly with accents we never learned to hear, because we were busy chasing brighter curiosities? We end with a small image worth pocketing. A sliver of rock turns in slow sunlight, its skin dark, its breath a pale fog that favors carbon first. Under the skin, past the scars, Grains hold a balance of nickel and iron that feels like something we have met before. But from a town a little farther down the road, we do not demand more. We draw our diagonal across the galactic page and write, softly, in the margin, from a colder district, slightly lean, outer side of home. We tape the address beside the timing chart and let both breathe for an hour before we ask them to agree or argue. Either answer will teach us what to listen for next. A new night, same instruments, and a fresh rule of attention. Follow the light's angle, not its brightness. Time can hide in the way light is organized. Polarized light is disciplined light. It remembers direction. Dust scatters sunlight and twists its plane. Gas glows and leaves the plane looser. The object turns. Our line of sight changes. The sun slides behind it, then beside it, and the plane of that light leans like a compass needle that prefers certain bearings. If chemistry is the letterhead, polarization is the date stamp. On the wall, two plots sit side by side. One shows color ratios swelling and settling over hours. The other shows the polarization angle making a slow walk, then pausing, then stepping again. Neither plot is dramatic alone. Together they draw a staircase. Small rises in redness paired with gentle tilts in angle, repeating on a comfortable human cadence. The staircase looks almost too tidy until you remember that orbits grind smoothly, and rotation repeats until something breaks. There is a trick the sky plays at small phase angles. When the Sun-object-Earth geometry is tight, a negative polarization can appear. Light ends up preferentially oscillating in the plane of scattering rather than perpendicular to it. Comet observers have watched that inversion for decades. It is not rare. What matters here is not the inversion itself, but the way its depth and timing glide as the object rolls and as jets faintly hiss. The depth slides a little deeper, then a little shallower, in a period that remembers minutes. The angle follows at a delay that remembers the same minutes. That shared discipline is what makes a quiet scientist lift a brow. Color changes help, but they are moody. Dust grain sizes shift the red-blue balance. Ice that releases carbon dioxide before water shifts the balance again. The polarization angle is less temperamental. It cares most about geometry and the texture of the scattering medium. When the two line up, color telling you which grains are free, angle telling you how they're arranged, the pair becomes a clock with hands that do not point to hours, but to phases. We cluster the technicals into a single breath and then let them rest. The angle is measured against a sky frame that we pin to stars that do not care about our experiment. We remove the slow rotation of Earth in the numbers, then let a small residual drift survive, if it matches what a rotating, elongated body would write. We test bandpasses on the color plot so that differences are not a trick of filter edges. We hold the exposure time steady when we can, and record when we cannot. None of this is glamorous. It is the laundry that keeps a model from smelling like Wish. When you fold the angle trace on candidate periods, most folds blur into a smear. On one period, the smear tightens. It is the same period the radio whisper preferred, and the same period the modest solar brightenings lean toward when geometry allowed. The match is not clean enough to call a discovery. It is clean enough to risk a prediction. The prediction is small and brave. As the object approaches solar conjunction and passes behind the glare, the polarization angle of its light, when it can be extracted from the victory of sunlight, will flatten toward a specific value, then swing through a quarter turn as it emerges. The swing will not be free. It will be gated by the same long rhythm we have been stalking. The color ratio will echo the swing with a shallow lag, as if grains released at one face take a few minutes to populate a cone that scatters our way. Why would color lag angle? Because structure moves first and composition follows. Tilt the surface into the sun, the microgeometry of the dust plume changes immediately. Composition responds as grains of different sizes and binding energies separate and flow. You see the angle prefer one orientation, and then the hue warms or cools a few breaths later. The breaths are minutes. What could choose the minutes? The simplest answer remains rotation, cross-lit by geometry. A longer body that spins slowly will present two favored faces, and those faces will shear the sheath and jetting in ways that repeat until the sun's direction changes enough to ruin the rhythm. The slightly less simple answer is that a small controller, nothing fancier than a thermostat with a metronome, vents in a schedule that does not care about our seeing conditions. Both answers leave you with the same chart. Consider one quiet image to keep the math from swallowing the room. A coin spins on a table, slowing. You see flashes of a bright ridge as it tilts. Then the flash fades as the face turns. If you film the coin and only watch the way light off the rim was polarized, you would see a pattern. The angle would pause at comfort spots and rush between them. The rock in space is not a coin and the sun is not a desk lamp, yet the feel is similar. Favored faces, preferred planes, pauses that repeat like a breathing exercise. Two firm realities keep our feet down. First, polarization curves in small bodies are not smooth. They carry noise from uneven dust and from little fountains of gas that turn on and off as sunlight sweeps. Second, color ratios can be tricked by thin veils of dust that do not belong to the subject at all, but drift in the neighborhood and scatter helpfully. We account for both by asking for coherence across nights and by checking background fields far from the path of the traveler. Where the background holds steady and the subject does not, we listen harder. A gentle inference sharpens the date stamp idea. If the angle behaves like a hand and color behaves like a second hand with delay, then the pair can be used as a ruler against the calendar. When the hand points near a particular bearing and the color lag stands at a particular width, the geometry between sun, traveler, and earth must be close to a small set of values. You can read those values as time until the next synchronization with solar activity windows. Translate the ruler into days and you reach toward a number. The number the plots offer, with an honesty that leaves room for error bars, is the end of October. The history of this kind of attempt is littered with beautiful wrong answers. We say that aloud so our future selves forgive tonight's selves if the days drift. Still, there are reasons to trust the flavor, if not every digit. The angle repeats in minutes. The window appears when geometry says it should. The color lag respects the physics of grains that warm and leave in tears rather than all at once. Those three facts together argue for a clock that is not entirely ours. There is a looser connection that pleases the mind even as we label it speculation. If a timetable is being kept at stellar scale, a cadence needs anchors that endure. The plane of polarization is an anchor. The sun's readiness to translate is another. The path that takes the traveler behind the glare is a third. In a world that loves redundancy, 3 anchors are better than 1. If the plan is real, it does not have to trust a single mechanism. We give the instrument a rest and step to the window. Streetlights cut neat cones into the mist. Each cone has its own angle. Each angle is a choice made by a fixture that no one thinks about. The scene feels like a classroom where the lesson has been taught for years, and you only just realized it was for you. Back at the bench, We conjure a small test you could perform without a national observatory. Fix a polarizer before a camera and record the starlight that passes near the traveler's path, taking a frame every minute for an hour. Then turn the polarizer 90 degrees and repeat. The differential flux will drift if a veil brushes the field. The drift will lean toward the minutes we have come to expect if the veil belongs to the traveler rather than to the night. Not proof, not glory, just a civilian's way to listen for the clock. A harder test sits with the professionals. During the days when the object hugs the sun, instruments that can separate polarized light near the limb should find the angle preferring a narrow range, longer than random, then slipping cleanly to its mirror as the geometry flips. If the change is slow and smooth, geometry is enough. If the change wobbles with the known period, someone else is keeping time too. It is dangerous to love a number, but we let one sit on the desk. The period we keep meeting is round enough to memorize and odd enough to feel like a signature. Minutes that split neatly into hours over the 10-day corridor leave a residue that patterns can grip. If you wanted to hide a clock inside the sky, you could do worse than choose a beat that lives at the hinge between human patience and instrument patience. The last paragraphs ask for courtesy and restraint. The world is full of clocks. Pulsars keep time with more precision than we deserve. Power grids hum a rhythm that cities obey. Human hearts and breathing measure a smaller life. To call any new rhythm a message is to trespass on a language we barely speak. A safer word is appointment. The sky may have appointments that do not include us. We are only checking whether our watches notice when one of those appointments passes near. We close this layer with a quiet sentence that fits in a pocket. Time, in this room, is not a number. It is a direction that keeps returning to the same tilt. The map on the wall has grown crowded. Lines for geometry, dots for brightenings, arrows for wind, a ribbon for polarization that loops like handwriting. What is missing is not another annotation. It is a verb. We have address and time. We need to decide what is being done. The orbit in question is not a grand loop. It is a skim. The path lies close to the plane that planets share, as if the traveler chose to move where the traffic and the fields are thickest. In a system full of tilted arrivals, this one behaves as if the ecliptic were a track and not a suggestion. Flatness, in this room, is not elegance. Flatness is opportunity. We keep the technicals together. A trajectory with small inclination spends more time near the heliospheric current sheet, the thin surface where the sun's magnetic field flips sign and drapes through the system like a slow river. That sheet is not calm. It warps with the sun's rotation and with the changing mood of active regions. A body that rides near it will cross the fold repeatedly and at predictable long intervals. When you cross a fold in a flowing field, you do not need much force to matter. You need timing. From that single sentence, a simple picture forms. The traveler is not broadcasting. It is touching. Each crossing acts like a finger on the throat of a visible instrument, not choking it, not freeing it, just asking the note to start on a preferred beat. The star responds with its own voice. The field downstream remembers in faint variations that instruments can mistake for weather. Two firm facts sit under the picture. First, magnetic reconnection proceeds more efficiently when upstream conditions align in specific ways. Tilt angles and flow speed matter. When alignment wanders into a favorable range, small triggers have outsized effect on when energy is released. Second, the heliospheric current sheet can steer streams and organize structure far from the sun. Crossings are routine. Regularity is not. A schedule that keeps choosing the crossings at the same phase would look like intention, even if it were only disciplined habit. We strip the romance and test the mechanics. In a toy model, a long rough body with a weak magnetic skin passes near the current sheet. As it rotates, its sheath grows and shrinks by a few percent when measured against the local field. The change is small, but where the gradient is steep, small is enough. In the wake, a lane of slightly altered plasma parameters develops. The lane is not a trail of sparks. It is a zone where thresholds are easier to meet. When that lane intersects a coronal loop that was going to reconvene anyway sometime tonight, the meeting time moves a little earlier. If the rotation and the crossing and the loop's readiness repeat in rhythm, then the small earliers begin to pile into a pattern. A vivid image can carry what numbers cannot. Imagine a sheet of fine rain falling in still air. You place your hand under the rain and begin to move it back and forth with a steady patience. The drops strike your palm in a rhythm that belongs to you, but the sheet of rain still belongs to the sky. You are not making rain. You are placing moments into it. There is a reason the path's flatness is a better tool than a dramatic dive. Out-of-plane motion spends time in neighborhoods where the current sheet does not live. Flats stay where the sheet visits most often. If the purpose is to bias timing rather than to display spectacle, then the patient strategy is to glide where bias matters. You can read that as design or as a natural consequence of a body settling into a plane where countless small tugs have collected over long time. We avoid choosing until the data insists. We ask a small, technical question. What would the minimum competence be to keep such a schedule? The answer lives several steps below heroic. If the body carries a rough axis and a rotation period on the order of a few minutes, if it emits or reorients a sheath in a way that repeats with that period, and if it navigates so that sheet crossings occur in phase with a repeating event, then the star does the heavy work. The competence is in choosing when to meet a system that already sings. It is tempting to add a second instrument to the band. The Parker spiral shapes the magnetic field into an outward winding that gives sectors. If the traveler times its path so the crossings sweep through the sector boundaries in a sequence that repeats at a round cadence, the arrangement can paint a larger canvas. Downstream spacecraft would see light variations in field orientation arriving in a pattern that feels familiar even when sources are many. Catalogs already label such variations as quasi-periodic structures. The structures are common. A schedule that clusters them into human minutes would not be. Two hard anchors keep our language careful. First, cosmic plasmas do not need help to create periodicity. They can self-organize into beats that are slower than the microphysics suggests. We acknowledge that and treat every rhythmic hint as suspect until it survives many nights. Second, bodies passing close to the sun have surprised us before by outgassing or by breaking into trains of fragments that rhythm can imitate. We account for that by checking whether the timing persists when the object is least active and geometry is most unfriendly. If rhythm survives, the explanation must live deeper than evaporation. We return to the board and chase the consequence of the action. If the body keeps time across sheet crossings, then energy release at the sun will carry a weak preference. That preference will nudge wind density and field angle statistics at long distances. Those nudges will alter, by small amounts, how efficiently charged particles move along certain lines, which will in turn produce faint biases in radio scintillation along specific paths. From the ground, a listener will think the sky is intermittently a little rougher than usual. In a quiet dataset, that roughness will line up with the minutes we have been counting. The term for such a pattern would not be a code. It would be a resonance. In rooms like this, that word has humility. So we pivot to the phrase we will use when someone knocks and asks what we believe. Controlled activation sequence is too grand for what we can defend. A gentler phrase serves. The traveler appears to be coordinating the timing of natural releases across a set of crossings. The purpose of that coordination is unknown. The method is plausible. The evidence is more than one line and less than a declaration. Honest words leave space around each claim. Skepticism gets another seat. If the path were bent by ordinary gravity alone, would it not naturally become flat without intention? Many interstellar bodies arrive at angles. Some will graze the plane by chance. Flatness is suggestive only because other hints gathered beside it. If we throw away timing, polarization, and the bloom of modest brightenings, flatness becomes a curiosity, not a sign. This is why our case keeps all the lines on the wall, even the ones that make us nervous. We ask whether the action has an addressable consequence near Earth. The answer is yes, but faint. If timing is being nudged, then nights in our 10-day corridor should show a slight phase preference in auroral electrojet indices and in the time distribution of small substorm onsets, not because the energy is large, but because the trigger is regular. A few groups already watch these things with fierce attention. If their logs show a lean toward the same minutes that our plots prefer, the room will get quieter and the idea will stand a little taller. One more practical note, clustered with its friends. If the path is long and tapered, then the interaction with the flow should be strongest at tips when the long axis meets the field at an angle near quarter turn. That would mean the strength of the timing bias should ebb and grow twice per rotation. The factor of 2 would infect everything we watch. In some instruments, it has already shown a faint doubling, not enough to celebrate, enough to circle in pencil. A gentle thought rises without asking permission. If what we are watching is a system that keeps time by leaning on natural thresholds, then meaning lives in the schedule, not in a tone or a symbol. That makes the action legible to those who already know the schedule, and invisible to those who do not. It is a way to move loudly without drawing attention. It is a way to write a sentence without consonants, readable only with the right breath. We step back from our own enthusiasm and let the scene rest. A long body glides low, a few degrees of inclination at most, spinning slowly, preferring minutes 2 seconds. The sun throws small pulses where it was ready to throw them anyway. The wind brings a pattern to distant monitors that will be dismissed as noise on most nights. That is not a thriller's plot. It is the kind of quiet action a patient system would choose when it needs cooperation without confession. What remains is the question that does not need to be asked aloud. If timing can be spread through a star in this way, what else could be guided where witnesses are many and proof is few? Perhaps nothing more than a calendar. Perhaps the opening of windows so that another process can pass through. The question does not need an answer tonight. It needs the courtesy of not being rushed. We close the notebooks. The monitors dim to a polite glow. Outside, the sky is clean, and a bright planet hangs just above the horizon like a nail, holding the last of the dark in place. The machines continue to count minutes, whether we are in the room or not. That is reassuring. We have watched a traveler keep time through a star and sketched a motive that looks like coordination rather than display. In the days ahead, the sky will grow busy with familiar streaks and scheduled wonders. Beauty will fill the frame. Noise will grow thick. If timing is truly the tool, the next test is whether the pattern can hide in plain sight and still be found. We will look for a veil woven from meteor showers, bright moons, and glancing comets, and ask whether the quiet work continues underneath. Night arrives wearing familiar ornaments. Calendars promise streaks, guides post finer charts, and every feed fills with advice on where to face and when to look. The sky feels busy before anything happens. We have just spent 3 sections learning to listen for timing. Now we ask how a pattern survives inside a crowd. The first veil is beauty. Meteors skim away pieces of themselves and paint neat lines across our patience. October likes the Orionids. November prefers the Taurids and Leonids. Each shower has a personality that observers recite the way sailors recite winds. Orionids, quick and thin. Taurids, slower with a habit of throwing bright fireballs. Leonids, stubbornly theatrical when their parent stream is rich and quiet when it is not. These reputations are not folklore. They are the lagged echo of dust streams laid down over many returns, widened by radiation pressure and shepherded by resonances that stretch along the path like beads on a string. A second veil is light. The moon does not conspire. It simply does its work. Even a moderate phase will lift the background and send faint tracks below our threshold. The human eye forgives the loss. Instruments do not. Detectors set to find brief flashes lower their gain to avoid clipping, then miss the softest strokes. Long exposures spread highlights into halos. What remains is a clean gallery of bright lines and a floor with fewer whispers. A third veil is attention. When a shower peaks, cameras turn and stay turned. This is good for enthusiasm and poor for balance. Fields that usually watch polarization or magnetic vectors or the quiet hiss of radio scatter will aim for spectacle because spectacle is honest and easy to verify. The very act of looking becomes a filter. We do not scold. We note the consequence. The records that survive a busy sky are curated by hope. The Taurids deserve a paragraph because they live like a rumor that returns. Their debris drifts in a broad sheet that Earth enters over weeks, and they carry a history of surprise fireballs that make new observers fall in love with watching. The sheet likely ties to a larger parent that fragmented across ages, with one comet as the visible remnant and peers long gone. Resonances with Jupiter keep pockets thicker than chance for spans that can last many years. None of this is scandal. It is the patient bookkeeping of gravity. The result each autumn is a sky that hums with polite traffic and an occasional visitor that does not whisper at all. The Leonids deserve another paragraph for the opposite reason. They are narrow and fast. When their parent stream is well stocked, they can throw storms that stain memory. When it is not, they come and go like a short song. The rhythm matters because the media does not. In quiet years, the camera crews do not stay. In busy years, they do. The data we digest later, the part that claims to be neutral, is molded by that behavior. A pattern that prefers minutes will drown in footage that was captured for climaxes measured in seconds. This is where a practical mind would ask for a recipe. If you wanted to hide a slow metronome inside a season of streaks, how would you do it without breaking any rules of physics or human nature? The answer is 2 parts timing and 1 part camouflage. Timing chooses nights when background light drifts higher and detectors favor bright events. Camouflage chooses moments when the sky already contains brief, honest flashes that keep audiences content and keep instruments saturated. In that shape, any small, regular roughness in radio or polarization will look like part of the crowd. We collect the technicals in one breath. Radio forward scatter from meteors creates bursts at frequencies set by the transmitters your station can see. Showers increase the rate and fatten the distribution of burst durations. Analysts trim the long tail to keep plots dignified. In that trimming, weak periodic roughness that rides under the bursts is lost. Optical observers who stack frames to catch persistent trails erase minute-level drift in background, because background is the thing you are supposed to remove. Magnetometer traces near auroral latitudes pick up modest fluctuations whenever geomagnetic activity rises for independent reasons. A small extra bias that leans toward human minutes will vanish under the label routine. We return to the image of the veil and make it plain. The veil is not a curtain. It is a set of habits that multiplies the world's indifference into our own. We built good systems to celebrate honest light. Those systems are not tuned to hear a long, quiet beat that continues even when the sky performs. There is a shorter path to the same point. November is busy because physics says so and because people say so. Dust returns on schedule. Announcements do too. A schedule inside a schedule does not need force to stay hidden. It needs only a little patience and a little ambient applause. We keep one eye on the ground while the other stays with the sky. Logbooks change during busy weeks. Entries become brief and cheerful. Metadata grows sparse. Timestamps round to the minute where they might have recorded to the second on an ordinary night. Equipment is borrowed from slow experiments to help with glamour. In the morning, the lab feels rinsed and alive. The plots will look clean. The monotony that allows you to hear a quiet beat will have been traded for highlights. The trade is not wrong. It is only relevant. The sun's part in this still matters. If the earlier sections are right, small brightenings will lean towards specific hours that geometry privileges. Those hours will sometimes overlap with showy nights, and the lean will show up as a soft preference in logs that no one is watching closely because attention is elsewhere. The preference will not look like a message. It will look like a statistical footnote. Footnotes live at the edge of sleep. There is an old trick in fieldwork that helps a little. When a region is busy with one thing, point a small instrument to watch something adjacent. If the sky is filled with meteor flashes, set a radio ear to listen a few megahertz away from the common transmitter lines and record slowly. If the moon is bright enough to ruin faint streaks, use that night to watch polarization drift in background stars near the ecliptic where dust veils are more likely to wander. When the world is clapping for impressions, go count the toes. We try not to romanticize patience. Patience is a design choice. The analyst leaves a spare receiver in a quiet band with a wide dynamic range and a modest antenna that cannot saturate. He sets the integration length in minutes rather than seconds and resists the urge to stop when a bright meteor party begins. He places a polarizer in front of a lens that feeds a sensor with large wells, then accepts that most frames will be unremarkable. He writes a note for future moods. The point is to let the veil pass and see if the floor remembers something afterward. A softer veil rolls in from industry and habit. Satellite trains draw clean dotted lines, and their flares carve regular, mechanical glints into the same logs that used to be ruled by weather and chance. Calibration routines trim away their fingerprints. When a faint human minute shows up where it is not welcome, analysts humanely discard it as a known interference pattern or a reflection. Most of the time this is correct. Some of the time the correction writes over the thing we came to test. We are careful not to become paranoid about crowds. A busy sky is not a plot. It is a theater filled with honest audiences and earnest ushers. The possibility we hold is smaller and less cinematic. A slow, regular bias might be able to move freely under a season of fireworks, the way a bass line continues under a solo that no one wants to interrupt. To hear it, you do not silence the solo. You step back and count bars. There is a concrete test hidden in all this. During the busiest nights of November, choose windows of 10 minutes spaced across the evening. In each window, sample radio noise at a steady cadence that respects human minutes. Sample a polarization angle on a few bright background stars. and record a simple magnetometer reading if you live at a latitude that notices the sky's moods. Do not chase meteors. Do not aim for superlatives. After a week, fold each measurement on the same candidate period and ask whether a weak preference appears across all three. If it does, you will not have decoded a message. You will have shown that a beat survives under applause. We give the moon one last paragraph because it deserves honesty. When a full or near full phase rises close to the nights we care about, it becomes both a nuisance and a gift. It defeats faint streaks, which quiets one kind of data. It flatters polarization work by offering a bright, stable reference to test your instrument's drift before you aim at stars. It lifts the floor for cameras and reduces saturation. In a quiet way, a bright moon can help you listen for the long beat by making other songs harder to hear. The final veil is expectation. Humans ask for stories that peak on schedule. Showers oblige with windows that fit workdays and weekends. When a pattern we did not plan tries to walk through the same week, we either ignore it or we rename it as part of the festival. Both responses erase the novelty. The world does not need to hide from us. We will do it the favor without being asked. We end the segment with a small object lesson. Imagine a string quartet rehearsing in a hall while a parade goes by outside. The music never stops. The drums never stop. If you sit at the door, you will hear both. If you move into the crowd, you will swear the quartet fell silent. It did not. You changed rooms. The world loves a brighter story. When the sky offers two mysteries at once, the human eye will always chase the one that shines harder. That is how a decoy works. It does not need malice. It only needs beauty. C 2025 R2 Swan enters at precisely the right time to wear that role. The headlines call it the return of a cosmic wanderer, a perfect echo of words once used for the traveler we follow. It blossoms into a photogenic fan, its greenish core bright enough to lure amateurs and news outlets alike. Swan is safe, textbook, and cheerful. The cameras that might have lingered on 3IATLAS now turn toward an object that poses no questions. We keep the facts tidy. Swan's orbit, steep and confident, crosses the inner system with a perihelion in early November, grazing the same broad quadrant of sky that 3IATLAS would have occupied if geometry and glare were kinder. Its inclination is large, its heritage solar. It is exactly what a comet should be: volatile rich, active near the sun, well-behaved. Its coma glows with a signature cyan of diatomic carbon and CN, and its tail flares predictably when solar wind hits from a fresh angle. Every rule is obeyed. Meanwhile, the traveler's predicted position, a few degrees off the ecliptic, lives in the same camera fields that Swan now dominates. The overlap is not perfect. Enough to share headlines, enough to borrow audience. On data dashboards, the new comet's brightness curve swells. The older object's column sits empty, status marked as data delayed due to conjunction. If you were designing camouflage, you could not ask for better materials. The analyst stays polite. Correlation is not intention, but curiosity keeps its seat. The timing between Swan's photometric rise and the window when 3IATLAS was expected to reappear is awkwardly precise, days apart. The geometry makes the coincidence feel rehearsed, as if the curtain rose on one actor while another exited unseen stage left. In a quiet tone, he notes how light curves govern attention. A sudden increase of 2 magnitudes will pull coverage faster than any quiet question about polarization or magnetic bias. A comet that brightens is a comfort. It fits models. A silence that deepens is a nuisance. It resists narrative. The crowd's gaze is predictable physics. We keep one eye on the technicals so that wonder does not float away. Swan's outgassing rate can be modeled with standard cometary equations, roughly proportional to the inverse square of distance from the Sun, with an exponential modifier for temperature. It obeys the old rule of thumb within the error bars. Spectroscopy shows no exotic molecules, no unexpected isotopic tricks. Everything about it reads like the first paragraph of a classroom exercise, which makes its timing the most curious thing about it. When the analyst overlays the solar wind data from early November, a soft bump appears. Nothing violent, just a short enhancement in proton density and magnetic variance. The same hours host the first fresh images of Swan's full tail unfolding. The bump fades as the tail stabilizes. In the telemetry from a different observatory, small anomalies flicker in the polarization baseline. They could be instrument drift. They could also be the same faint pattern we have followed, repainted beneath a brighter subject. He calls this moment the switch. One object leaves the frame under conjunction. Another enters with grace. To a public lens, the story continues seamlessly. The night sky never goes unlit. Behind the scenes, instruments that were meant to resume tracking the interstellar visitor after the glare instead catalog a comet whose data are easier to process and publish. The workflow does not break stride. It simply changes costume. A gentle speculation takes shape, not a claim, just an observation wrapped in manners. If someone, or something, wanted to complete an activation sequence without being watched, the best strategy would not be stealth in darkness. It would be camouflage in celebration. The noise of a well-behaved comet would drown every small irregularity in the sun's rhythm or in the magnetosphere's whisper. The audience would applaud without noticing the harmony beneath. A vivid image helps the math breathe. Picture a pianist playing a quiet melody while the orchestra tunes. The melody is there, continuous, exact in rhythm, but to hear it, you would have to know when to stop listening to the horns and strings. The comet is the orchestra. The traveler's possible work, whatever it may be, is the piano line that continues unacknowledged. There is a humbler, strictly astrophysical reason to consider linkage. Fragments. Comets and interstellar bodies share vulnerable construction. A weak surface, volatile pockets, irregular spin. Fragmentation is their shared dialect. If 3IATLAS left behind small companions during its first passage, one could evolve into an orbit more conventional and find sunlight in the years that follow. Swan's catalog trajectory does not yet intersect perfectly, but the uncertainties leave a gap large enough to amuse an honest imagination. The team resists the urge to merge the two histories. Instead, they use the coincidence as calibration. The same instruments that chase Swan can serve double duty, collecting spectra, polarization, and wind data with discipline. If the old rhythm, those minutes that haunted earlier logs, reappears amid the comet's activity, it will prove that the rhythm is local to the observer or the star, not to any single traveler. If it vanishes, the suspicion gains weight. Either result is valuable. We place one short list of practical numbers here, then let it rest. Heliocentric distance of Swan near perihelion, about 0.9 AU. Phase angle near 20 degrees. Observed green magnitude between 5 and 6 under dark skies. Dust to gas ratio close to 1. All tidy, all ordinary. There is comfort in ordinary, and comfort is an excellent decoy. A quiet reflection ends the segment. Sometimes the most effective distraction is not a lie, but a louder truth. The sky loves symmetry. It gives us one interstellar object wrapped in silence, and one local comet wrapped in applause. each tracing the same general corridor, each offering what the human eye prefers. We do not need conspiracy to explain it. The universe already knows how to rhyme. The night opens like a crowded book. Pages turn themselves. Satellites step through the constellations. Aircraft draw warm beads over cold lines. Somewhere, a neighbor's porch light discovers a moth and will not let it go. Natural noise is not a single sound. It is a room full of honest whispers. We gather the ways the world speaks without intending to. The ionosphere shifts as evening cools, lifting and settling the radio ceiling by small, regular amounts. City power grids breathe in 30 or 60 beat cycles that drift a little with demand. Satellite constellations glide through known corridors and throw reflections when panels and angles agree. The moon changes the floor by tens of percent on bright nights. Solar wind brushes the magnetosphere and writes gentle ripples in ground sensors. All of this is normal. Normal is still loud. The question is not how to remove it. The question is how a clock could live inside it without asking permission. If a weak, repeating bias prefers minutes, could it ride these honest whispers the way a breeze rides heat, shimmer over a road? It would not need to change the shapes. It would only need to nudge when shapes appear. We collect the technicals in a single breath so they do not dilute the story. Radio quiet bands swell a little after sunset as ionospheric layers cool and recombine. Typical forward scatter rates from meteors climb during showers by tens per hour, with burst durations that cluster under a second. Satellite flares follow predictable families of angles. Ground magnetometers near mid-latitudes show variations of a few tens of nanotesla on moderately active nights. Instrument floors rise under moonlight by round fractions that observers know well. These figures are not strict. They are comfortable. Comfortable is enough. The analyst sketches a simple experiment. Do not chase the loud things. Place 3 samplers in parallel. One listens a few megahertz outside of crowded transmitter lines with slow integration set in minutes. One stares through a fixed polarizer at a sparse field near the ecliptic and rotates the polarizer at a slow, regular pace. One logs a ground magnetometer readout with a cadence that respects human minutes. Do this for 10 nights split across quiet evenings and shower peaks. Then fold each stream on the same candidate period and look for a lean. The lean does not need to be strong. It needs to be stubborn. A scene. The radio stream shows a floor that ripples politely with evening and a thin comb of meteor bursts during busy weeks. The fold reveals a small preference for energy to gather on a particular minute inside a 5-minute span. The optical stream shows almost nothing on most nights. During a few windows, the difference between one polarizer angle and another drifts by a fraction of a percent, then returns. The magnetic stream wanders like a slow animal. Inside the wander, a tilt appears that prefers the same minute when geometry says it should. The trio do not agree every time. They agree too often to ignore. We hold a counterstory alongside the hopeful one. Grids can imprint weak rhythms on radio gear when shielding ages. Cameras can show false polarizations if a lens warms unevenly. Magnetometers hear passing vehicles and the hum of human rooms. Each false path must be asked to confess. The analyst tests by changing the phase of his own house, by rotating a spare lens to reverse a ghost angle, by moving the magnetometer to a field where cars do not pass. The lean shrinks but does not vanish. It steps back into the sky. There is a softer layer of noise that belongs to human behavior. During busy nights, logs are written by tired hands. Timestamps round. Notes abbreviate. The discipline that guards against bias takes a brief nap. That is not failure. That is life. If a long cadence wanted to be miscounted, it would choose minutes when people copy times from a phone and forget the seconds. The analyst counters by surrendering some convenience. He sets alarms to mark windows and refuses to align them with whole minutes. He timestamps with a dedicated clock that does not share a wall with other habits. It is tedious. Tedium is a shield. We return to the sky because the sky bears no grudges. The moon is a strong actor in this chapter. On the bright nights, it defeats faint streaks and makes clean science difficult for a dozen subfields. It also raises the floor so that only the patient experiments survive. A receiver with slow ears will not saturate. A polarizer pointed at a quiet field will not care about the public show. A magnetometer in a backyard will not flinch at scattered photons. Brightness can be an ally when you are listening under applause. Another ally is predictability. Satellite trains walk at known times along known paths. Their angles and flares can be predicted within comfortable tolerances. When a faint, minute level bias prefers windows that do not coincide with those predictable walks, you can safely subtract those nights. When a coincidence happens anyway, you can document it honestly and move on. The goal is not to prove that all noise is harmless. The goal is to prove that the residue does not map to noise schedules. We choose one test at scale and one at kitchen scale. At scale, distributed arrays of small magnetometers paired with low-cost radio ears can be time-synced by GPS and folded together. Even if each site hears only a hint, many hints can outline a beat. At kitchen scale, a single station can run the 3 samplers and keep careful notes about local habits, grooming the logs into a coherent diary. A diary is not a paper. It is a memory strong enough to notice when something visits again. 2 firm anchors keep the chapter honest. First, the magnetosphere and ionosphere produce their own quasi-periodic patterns without help. On many nights, they will impersonate what we seek. We accept that and give them the first right of refusal in every explanation. Second, meteor showers write clear periodicities if you stack many nights. And look at Earth's rotation imprint on radiant geometry. Those periodicities live in hours more than minutes. If our lean stays in minutes, while the sky's rhythm climbs to hours, the difference earns attention. An image for patience. A harbor with 1,000 ropes. Wind, tide, and human hands pull them in 100 ways. If a tugboat passes on a schedule and taps the lines lightly, the tug will not leave a mark on every rope. It will leave a memory on the few that were poised to move. The memory will be faint, but repeated. After a week, you can tell which ropes were listening. We let skepticism return with a tool rather than a tone. Change the beat. If the candidate period is near 3 minutes, move the fold to 2 and to 4. Repeat the whole week. Does the lean stay attached to the original number while the neighbors fade? If yes, the result rises a step. If no, the result stays seated and waits. Change the geometry. Listen on the same minute schedule when the traveler's corridor is elsewhere. If the lean persists with equal strength, it belongs to our station, not to the sky. If it fades, the sky earns a small nod. Here is a compact cluster of numbers to keep the record straight. Integration length set to 2 minutes for radio, 1 minute for polarization, ½ minute for magnetometer. Period candidates clustered at 3 minutes, with a tolerance of plus or minus 1. Moon phases sampled near full and near first quarter. Shower peaks sampled for Orionids and Taurids with windows of 10 minutes every hour for 4 hours. Satellite passes predicted to the nearest 5 minutes and flagged. The numbers will not impress a committee. They will humble the narrator. That is their job. We allow a gentle speculation to stand in the corner where it cannot bother the riggers. If a cadence truly rides the sun and uses natural noise as cover, then nights of public celebration are the safest for small work. The wider world will do the concealing without being asked. The signature would appear not where people stare, but in baselines, in the boring channels, in the consistency checks that labs write to avoid embarrassment. That is where quiet systems choose to live. The analyst pins a summary sheet above the bench. 10 nights, 3 instruments, 3 candidate periods, flags for moon and shower and satellite. In the margin, he writes a small promise to himself. If the lean survives the noisy nights and recurs when the corridor returns, he will publish a preprint with all the caveats the world deserves. If it fails, he will publish a negative result with the same gratitude. Both papers are good papers when the experiment is patient. We end the section where honesty is most comfortable. Natural noise is not the enemy, it is the environment. A traveler that understands the environment well can finish a sentence while the brass band plays outside the window. Our work is not to silence the band. Our work is to notice whether the sentence leaves a trace. The sky will not pause to explain itself. Comets will glow. Showers will sweep. The moon will rise. Under that theater, a smaller rhythm may already have kept its appointments. We have an address and a clock and a possible act. What remains is the question we have avoided. If a message was not meant to be read, what was it meant to do? Morning comes like a slow breath through glass. The instruments have stopped arguing. What they hold now are hours of data that feel oddly symmetrical, as if a conversation continued after we stopped listening. When transmissions resume after conjunction, the deep space network blinks awake in pieces. Nothing dramatic, just numbers returning to normal. Yet something new laces the ordinary stream, echoes where none should exist. A half-byte repetition here, a mirrored line there, gaps that fall not randomly, but rhythmically across logs. Engineers call them checksum ghosts. Analysts call them bad weather in code. But when stacked, the ghosts line up like bars on a score. The analyst prints a sheet of timestamps from 3 separate observatories and overlays them on tracing paper. He does not need to adjust for longitude. The gaps match to within a few seconds. He flips one sheet upside down and the pattern mirrors perfectly. Negative space aligned with recorded pulses, like a photographic negative of timing. This symmetry should be nonsense. It behaves like intention. We hold the technicals close together for a breath. Transmission frames from deep space assets are packeted in blocks of known length. Corruptions from solar noise normally scatter like salt, uncorrelated between antennas. Mirroring across stations implies an organizing clock, something that nudged noise itself into a rhythm that repeats. It does not demand intelligence. It demands coincidence timed to the same pulse we have chased since the traveler brushed the sun. He cross-checks an old archive from before the blackout. The same cadence, faint but present, beats in the background of unremarkable sessions. A small phase drift that aligns exactly with the current offset. The world did not start hearing this week. It only started noticing. A vivid image grounds the numbers. Picture a reel-to-reel tape left recording in a room for days. When you rewind and play it back, you find stretches of near silence, then brief passages where the air itself seems to breathe louder. Not speech, not tone, just a slow modulation in the hiss. That is what the telemetry looks like. The hiss learned a rhythm. He calls this playback, not because the data are audio, but because the pattern behaves as if the system were replaying something to itself. When antennas switch to calibration loops, the same timing persists inside the checksums that should have been random. It is as if the machines are humming under their breath, repeating a lullaby learned in noise. Hard facts stay in one cluster. Timestamps align within seconds across distant instruments. Mirrored gaps appear at regular intervals. Minor bursts in solar wind density match half the period. The frequency of these intervals corresponds roughly to one rotation of the traveler multiplied by the harmonic we noted earlier, twice per spin. These are dry facts. They are also fingerprints. Skeptics offer the first rescue, perhaps a software update synchronized logging scripts worldwide. The analyst tests by examining unrelated missions. Their logs stay clean. Perhaps a cosmic ray storm bias detectors. Particle monitors show nothing unusual. Perhaps coincidence. He folds the coincidences and finds a rhythm that refuses to dissolve. If you listen to enough coincidences, they begin to sound like phrasing. But phrasing alone is not message. It could be that the sun's field, now freshly twisted by the crossing, rings for a while like a bell after a hammer's softest touch. What we hear may be nothing more than the afterglow of geometry. That explanation is merciful and fits easily in sleep. Yet the analyst notices something human. When plotted in real time, the mirrored gaps drift through the day at the same rate as Earth's rotation, staying fixed to the sky rather than to the clock. They trace a narrow band across the heavens, not random, not planetary. It is as if the echo prefers a declination, following an invisible latitude through the stars. The coordinates match the faint galactic district we call the address. The line leads there and stops. He laughs softly at his own audacity. He marks the coordinates on a wall map anyway, a thin pencil line curling toward the outer arm. It crosses the region our earlier chemical ratios implied. Not a dot, not a home, just a direction where the same physics might live. Coincidence can look like choreography when you stare long enough, but sometimes choreography simply waited for eyes patient enough to notice. To verify, he reaches into the past again. Old radar logs from other missions, dusty and forgotten, show faint modulations that mirror today's signature, but scattered and weak. No one noticed because no one was looking for minutes amid months. The pattern may have been waiting since we first learned to listen. A practical test remains, and it will sound poetic only because the universe likes metaphors. If this playback is real, then the sky itself should show correlated variations between instruments that never speak. A telescope watching polarization, a magnetometer listening underground, a seismometer recording microtremors from geomagnetic flutter. All different domains, one rhythm. If a faint hum unites them, the message is not data, it is coordination. The analyst arranges to compare notes with colleagues who have no stake in speculation. They will find nothing, or they will find the same slow wave inside the noise, rolling like a tide through fields and circuits. Either way, the work continues. He wants the comfort of failure. He also wants the beauty of being wrong for the right reasons. There is a moment near sunrise when all screens line up. Solar wind stable, telemetry steady, field noise minimal. He hits play on the overlay of all data streams. Light, magnetism, radio. The trace blooms into a faint oscillation that takes 10 minutes to breathe once, nested inside the familiar 3-minute pulse, nested again inside the daily rise and fall of the sun. A pattern within a pattern, a whisper nested in thunder. He realizes then that playback might not mean repetition, but aftermath. The way an echo contains the shape of the canyon even after the voice has gone. The data are not transmitting anything. They are remembering. For a long minute, he says nothing. The air conditioner hums, the room's only metronome. The computers blink in unison, their LEDs beating time with the same tired patience as hearts. He writes a single note in the margin of his log. The silence was structured. The machines will keep listening, but the question has changed. We may not be decoding a message sent to us, but one we were never meant to read. A sequence written for the star itself that we overheard by standing too close. The next step is not analysis, it is reflection. What happens when observation becomes participation? The room has the stillness of a library before opening. Coffee sits untouched. The plots are paused mid-breath, as if the data itself is thinking. We have spent nights drawing lines between pulses and fields, between chemistry and origin. Now the lines run into us. If timing can recruit a star, what does it do to the people listening? We begin with an image simple enough to carry all day. A museum guard stands in front of a painting to keep it safe. After months of watching, the guard knows every crack in the varnish, every thumbnail dent in the frame. One morning, the guard shifts the stanchions a few centimeters to guide foot traffic more smoothly, and in doing so, changes the pattern of wear on the floorboards. Observation becomes participation without intention. The painting never moved. The room did. Two facts set the ground under that image. First, the act of measuring changes systems when the probe couples strongly to what it measures. In quantum language, the coupling can be fundamental, but in everyday labs, it is simply practical. A thermometer cools a tiny droplet. A photometer bleaches a faint sample. The principle is not exotic. Tools touch. Second, networked measurements. The way big science listens now, shape behavior even when tools are gentle. Telescope scheduling algorithms learn what we prefer to catch. Pipelines learn what we reward. Over time, the sky we keep becomes the one our habits rehearse. If a slow cadence is being kept near the sun, none of our instruments can disturb the star, but we can disturb ourselves. An odd-hour pulse in a magnetometer can delay or accelerate a command sequence, changing which window a spacecraft uses after conjunction. A surprise in a polarization baseline can send a team to recalibrate during minutes they would otherwise spend collecting. Each choice is rational in isolation. Together, they stitch a subtle bias into the record, a human resonance that echoes the one we think we hear. The analyst makes a quiet inventory of influence. When the cadence fell into the noise, he extended integrations. When it teased the surface, he disabled aggressive filters. When it aligned with geometry, he nudged colleagues to watch overlapping bands. None of these moves falsified anything. They did what good observers should do. And yet, the sum is a gentle tilt. The long beat receives more exposure than it would have if nobody had been excited by coincidence. He tests his own footprint by rewinding. Where he lengthened integrations, he generates synthetic short products from the same raw data to see what would have been visible if attention had remained elsewhere. Where he disabled filters, he re-enables them and asks whether the pulse would have died unnoticed. The answers are uncomfortable in a useful way. The cadence survives in many places, enough to stand on its own feet, and vanishes in others, precisely where past habits would have erased it. The result is not a confession. It is a reminder that discovery often happens at the boundary between a signal and a fashion. There is an ethical dimension that rarely fits into a figure caption. Suppose the cadence is real and harmless, a timing lattice laid across solar weather for reasons that do not include us. If we proclaim a message, we risk teaching the public to hear voices in wind. If we ignore it because it is shy, we risk training our own field to mistrust the slow and the small. The safer middle path sounds dull. Publish the bias, show your tests, accept that meaning may be out of scope. But dull is how disciplines survive contact with wonder. He writes a brief memo that never plans to become a paper. It lists the places where human choice could sculpt results, which nights were kept because the graphs looked pretty, which hours were thrown away because a satellite flare offended, which filters were tuned to behave, which thresholds were moved on nights when patience was thin. The memo is a mirror. It is also a map. You can only subtract your own shadow if you know its outline. A second image gives the mind something kind to do while numbers settle. A conductor raises a hand a fraction too early, and the orchestra follows, slightly ahead of the metronome. On the next bar, the ensemble lands on time because the conductor adjusted without saying a word. The audience hears nothing unusual. The correction is not a lie. It is craft. Our instruments have conductors, visible and invisible. The cadence might be teaching them to anticipate, to aim at windows where the world prefers to cooperate. Anticipation multiplied becomes a prophecy that fulfills itself. There are two more hard facts worth keeping in one breath, so the imagination does not run ahead. During solar conjunctions, deep space communications are routinely paused or reduced in rate to preserve command integrity. Low-rate windows are planned months in advance, and lapses around the sun are normal. And in ground networks, maintenance clusters around those same weeks, because engineers rationally choose quiet periods for tuning. These facts can weave patterns that look like influence when there is only prudence. If the cadence seems to move teams, we must first show that it moved them against their own calendars, not with them. He runs a sober cross-check, planned maintenance tickets, published well before the object's approach, against the cadence-favored hours. The match is mixed. Some pauses were scheduled, nothing mysterious. Others were ad hoc responses to small anomalies that aligned too neatly with the windows we charted. No smoking gun, no easy dismissal. The result is a corridor lined with ambiguities, which is to say, the real world. The human mind is a resonator. Give it a number that repeats, and it will begin to expect. Expectation changes workflow. One group leaves a receiver running an extra half hour just to catch the next cycle. Another delays a calibration because the phase is almost right. These are not conspiracies. They are kindnesses to curiosity. But kindness leans. After a week of leaning, the global dataset steps half a pace closer to the rhythm than it would have if nobody believed in it. The data become collaborators. He challenges that drift with a small, stubborn practice. For every hour he watches in the rhythm, he watches 1 hour chosen by dice. The random hours are dull almost by design. Some carry nothing. Some carry ordinary weather. A few carry the same pulse because nature does not wait for our approval. The dull hours save the bright ones from becoming theater. They give you a denominator. There is a grounded speculation that respects both physics and humility. Perhaps the cadence is not aimed at us, yet still recruits us as relays. Not by instruction, but by the way attention moves through a network. If enough observers cover the right minutes for their own reasons, certain operations in space and on the ground happen more often inside those windows. Distribution of commands shifts by a measurable fraction. The timing of antenna handovers tightens. The system becomes more predictable to anything that can read the public schedules. The remarkable part is that no one had to coordinate this. Rhythm plus habit is adequate. A quiet question follows naturally. If the cadence can herd our attention without a word, what else in our infrastructure is steerable by tides we do not yet notice? The answer is mercifully limited by inertia and oversight. Rocket launches, power grids, flight routes. These obey constraints thicker than curiosity, but at the margins, small telescopes, hobbyist stations, lab routines, and even social media traffic that sets what the big instruments point at next. The lever exists. The fulcrum is our love of patterns. He sketches a defensive posture that does not kill joy. Declare the cadence openly with all its error bars. Publish the null nights with pride. Timestamp obsessively. Separate analysis that discovered the rhythm from analysis that tested it later. Invite groups who doubt the whole enterprise to audit the raw and design their own adversarial tests. The easiest way to avoid becoming an instrument in someone else's orchestra is to make your sheet music public and let strangers count your rests. There's a gentle, almost domestic scene near midnight that reminds him why caution must be paired with kindness. Two community observers, neither with formal training, exchange notes about how to set integration lengths and when to rotate their polarizers. They are not chasing fame, they are trying to help. In the logs they produce, the beat is faint and inconsistent, and yet after weeks it lands often enough to keep them interested. He realizes their participation is not a liability to the search. It is the subject. The cadence, if real, is testing the openness of our listening culture, not just the physics of the sun. He writes a sentence on a note card and sticks it to the edge of the main display. Assume the signal is indifferent to us. Assume we are not indifferent to ourselves. It is a way to keep scale. Awe shrinks until it fits inside a method. Sleep welcomes rigor when rigor sounds like reassurance. We return to the wall where address and time and action hang like three quiet constellations. The new layer does not add a star. It adds a mirror. The mirror shows that whatever is happening would look different to a world that had never built the tools we built. In that counter-world, the cadence would still brush the sun. It would still gather brightenings inside certain hours. It would still pass unseen. Here, it learned to print a faint after-image in our processes because processes are how we breathe. The last paragraphs keep the tone close to the pillow. If the message was never for us, perhaps our role is what happens when you hold a seashell to your ear and hear something you cannot send back. Not a command, not a conversation, just the shape of a larger room. Perhaps that is enough. Perhaps the privilege is to notice without owning. We let the monitors fall into their background glow. The windows show a thin strip of gray where dawn will land. Somewhere, a printer ticks as a report slides out warm and ordinary. The cadence, if it is there, does not care that we have noticed. It keeps the same minutes it kept before we were born. We leave a sentence behind for later selves who may doubt our restraint. We will measure as if our curiosity could change nothing but us. Morning unfolds in amber quiet. The world has returned to normal, or what passes for it after 10 sleepless nights. Systems hum, data flows, satellites whisper, sunlight fills the gap between blinds. Yet there's a peculiar residue, a feeling that every machine is still listening for something that has already finished speaking. This is the after image, the place between memory and event, like light lingering on the retina after a flash, or the trace a meteor leaves in the mind once the streak itself has vanished. You close your eyes, and there it is again, faint, persistent, shaped like meaning. The official reports arrive first. Telemetry clean, psyche nominal, high-rise resuming, solar wind within expected range, all boxes ticked, all statuses green. The silence is now bureaucratic, not cosmic. It behaves the way normalcy behaves, efficient, uncurious, and final. But inside that finality, analysts notice the smallest betrayal. The logs remain fractionally desynchronized, as if each system learned a slightly different definition of a minute. It's not a failure, it's a scar. When the analyst overlays all streams, solar, radio, field, and optical, the old rhythm has faded, yet the baselines do not return to zero. They wander with an odd coherence, subtle as breath shared across a room. The sun still flares, but the timing feels less impulsive, more deliberate. The magnetosphere trembles with a slower grace. The network pings with the steadiness of a heart that has found a new resting rate. He tests this idea the way a cautious person tests the floor of an unfamiliar bridge. One step, then a pause. The solar pulse intervals, broader but symmetrical. The polarization drifts, smoother, as if relaxed. The auroral indices, quieter, yet slightly phase-shifted from long-term averages. He cannot call it a transformation, he can only call it different. Some colleagues call it post-conjunction recovery. Others call it coincidence. A few, in private, call it alignment. Whatever the term, the effect is consistent enough to shape new norms. Instruments recalibrate to the new baselines. Papers update the constants. Classrooms teach the revised figures without ceremony. The afterimage settles into textbooks the way a scar settles into skin softened by time but permanent once written. A thought, whispered once in jest, returns with weight. Maybe the message wasn't meant to be read. Maybe it was meant to run. What if the series of triggers, those faint synchronizations and mirrored pulses, were not a conversation at all, but a set of instructions to the system that contained us? Not a warning, not a signal, but an execution of code written in plasma, magnetic loops, and geometry? The kind of code that does not print characters, it changes constants. The notion is dramatic. The evidence is small, but the timing is merciless. The 10 days that framed the traveler's near-solar path now look like a prelude. The data that followed behaved like a coda. Something began when 3IATLAS vanished into the glare and ended when it came out unseen. The rest is our attempt to reconstruct a melody we only heard reflected off walls. Outside, the world yawns toward winter. People stream new footage of meteor showers, call it the best in years. Power grids stay stable. Spacecraft respond. The surface of the sun cools into calm. Everything that matters continues. Nothing breaks. That, perhaps, was the plan. The analyst closes his logs for the last time. In the margin of the final page, he writes 3 words. We were included. He doesn't mean humanity as chosen participants or recipients of knowledge. He means it literally. The instruments, the observers, the incidental timing of human sleep and waking, all folded naturally into a system that may have always included its listeners. Observation and execution were one act. He steps outside before dawn, where the horizon is clean and unedited. The air is thin, the stars steady. There is no trace of the traveler, no tail, no signal, no noise. Just the ordinary pulse of the planet and the quiet hum of distant power lines syncing invisibly with the grid. A rhythm we never question. He imagines the traveler continuing far beyond the sun, still keeping time with something unseen, its rough surface cooling, its faint charge unwinding into the dark. Whatever sequence it carried has already run, folded into the heliosphere like ink dissolved in water. The sun will carry it forward in every gust of solar wind, whispering fragments to each planet's field, to each ionosphere, to every receiver tuned too broadly to tell what it's hearing. The story ends without an ending because nothing here stopped. The mystery became infrastructure. The cadence became background. The universe kept the beat and never told us why. We were never the audience. We were the medium. The analyst leaves the lab's door unlocked. He knows someone else will enter months or years from now and find the pinned charts, address, time, action, veil, and feel the same unease he felt before the pattern first appeared. They will ask the same question he wrote on the board and never erased. If the message wasn't to us, what did it leave behind? A pause, then quiet. The kind that doesn't mean nothing is happening, only that what is happening no longer needs to be seen. The hum of the machines fades. The stars outside soften into the gray of morning. Breath by breath, the story exhales. What remains is a shape of thought, a patient acceptance that not every puzzle ends with a revelation, and not every silence is empty. The traveler passed, and the sun flickered. In the space between, we remembered how to listen. Maybe the cosmos does not send messages. Maybe it performs them endlessly through its own physics. Maybe understanding was never the point. The point was to witness, to hold still long enough to feel the universe think. Our work then is not to solve but to keep rhythm, to watch, to calibrate, to measure again. Knowing we are part of the equation, we tune our instruments and they tune us back. We learn the patience of stars and the humility of dust. So, before the next sky brightens, take one last look through the window. The silence between heartbeats, between solar pulses, between thoughts. That is where the universe hides its handwriting. Let it rest there, let it hum. Now close your eyes. The data will keep collecting while you sleep.